Hey everybody, I hope you enjoyed your 4-day weekend, had a chance to relax and get out and do something fun, 6 feet apart from everybody else, I guess. But we have to talk about that lab from last week. And the point of that lab was to help you get an opportunity to develop some of the conceptual relationships between what affects the period in a pendulum and a mass on a spring, and even some mathematical relationships. So we're going to go over the lab actually in the order of the lab and just say what had an effect and what did not. So the first thing, for the pendulum, the initial displacement. So this is a little sneaky. Most of you said that as the angle got larger, the period got larger. And this is for the most part true. And if you said that, you didn't lose any points. However, this is how we're going to treat it. The assumption is 10 degrees or less will have no effect. So if you looked at your data, you would see that when it was less than 10 degrees, the times were pretty much the same. When it got more than 10 degrees, it made a difference. So the assumption is 10 degrees or less has no effect. If it's more than 10 degrees, then the period would increase. So keep that in the back of your mind. The next thing you did was to see if mass had an effect. Well, most of you got that one right. Mass has no effect. Gravity is the reason that the pendulum swings back to its equilibrium position. And all year, if it's just something falling or if it's just the normal force, gravity, and friction, we know that mass just divides out. Mass has not usually had an effect if it's only gravity acting on the object. Speaking of gravity, gravity has an effect for sure. Gravity had an effect. Has an effect, definitely. As you saw, if the gravity increased, like when you went to Jupiter, if the gravity went up, the period went down, and obviously vice versa. So I wouldn't go so far as to call them an inverse relationship. It turns out it's close, but not quite to an inverse relationship. And then finally, length definitely has an effect. That was easy to see. And you notice that as the length increased, so did the period. You were supposed to graph this, okay? And most of you did an excellent job graphing this. It looked something like period on the Y, length on the X, and you got a shape that looked something like that. It should not have been linear. In fact, you should have gotten Y equals some number, I don't know what it was, times X to the 0.5 power. And that's the most important thing. So this said that there is a square root relationship. So that was the important thing. It's not linear and it's not direct. There is a square root relationship between length and period. So those were all the concepts and a little bit of mathematical. We're going to put this all together soon enough. When it comes to the mass on the spring, so the first thing that we tested was to see if gravity had an effect on the mass on the spring. Now, some of you got answers that were very similar, or it would go up for one and down for another, but there was no distinct pattern. But then you wrote that there was a pattern, but that's all right. But there is no effect. Gravity has no effect on a mass on a spring. Has no effect. Remember, you were timing it yourself. So there's some uncertainty. So if the numbers were near each other, they're basically the same. The next thing that we tested was mass. Was the spring constant. So the spring constant has an effect, definitely. And you correctly noticed that as the spring constant got smaller, the period would increase. And of course, vice versa. No need to write it twice. Now, the last thing that we tested was the mass having effect, but before we talk about that, the initial displacement. This was a little questionable for some people, but the initial displacement has no effect. No effect. Again, if you timed it yourself and the numbers were reasonably close to each other without any necessary pattern, it has no effect. The last thing that you did was the mass, and yeah, it's a mass on a spring. The mass has an effect. That's pretty straightforward. And if you did this correctly, which most of you did, you saw that as the mass increased, the period increased, and hey, guess what? When you graphed it, you noticed that the shape looked like that. And again, you should have gotten something that y equals some number, again, I don't know what that number is, times x to nearly the 0.5 power, excuse me. Some of you were close, like a 0.4 something or 0.5 something, but basically it's the 1/2 power. And hey, guess what? There is a square root relationship. That's what you were supposed to see. It's definitely not linear. So these are the concepts. It's actually good to have them out, in your notes. This can always remind you as you're doing problems what makes a difference and what doesn't. So I would suggest having them out as you do your homeworks. It's a summary of everything that you were supposed to learn. Normally we would be doing this in a classroom setting where each group took one or two of these things to study, and then we would share our results. But it is what it is for now. So the last thing we have to do is take all of this and put this into a mathematical relationship. So here we go with that. So based on the concepts that we got from the lab, when it comes to a pendulum, we know that the mass has no effect, and assuming the initial displacement is less than 10 degrees, the initial displacement has no effect. So neither of those will be in our equation. So here's how it plays out. We knew that the period is directly proportional to the square root of the length. It was a square root relationship. So there's a 2 pi sneaking in here, and then there has to be a square root. Normally in class we would be talking about where we should put the length, but I think it should be numerator, denominator. As the length increased, the period increased. I assume that should be in the numerator. So there's that. And then as gravity increased, the period decreased. Turns out that is actually in the denominator of the radical. It is an inverse square root relationship. But that's the math. It's pretty much that's it. But T and G have an inverse square root relationship. Not indirect. Some of you said that. Don't say that. That's dirty. Inverse square root relationship. Again, notice there is no mass in this equation, and there's no initial displacement. Mass on a spring, very similar. Period is proportional, or equal, to 2 pi. There's going to be another radical. We already saw that as mass increased, the period increased, and we said it was a square root relationship. Terrific, that goes in the numerator. As you can probably imagine where to put the spring constant, because as the spring constant became less, the period became more, or vice versa. So that's going to be in the denominator. And again, period and spring constant, inverse square root relationship. Weird, but that's what it is. So these are pretty much substitute and solve expressions. Every year people are unsure when to use which one. Don't be one of those people, because it's really straightforward. Like this one literally says mass on spring, M and spring constant. Like that's the one for a mass on a spring. This is a length of string, and gravity is the reason that this thing swings back and forth. That's a pendulum. So it's really not that difficult to figure out when to use which equation. One thing I do want to bring to your attention is when you're doing the math, Okay. Order of operations is essential. Basic algebra skills, be careful. Let's say you're solving for length. Just as an example, here's a couple things. When you start off, and you're going to probably divide both sides by 2 pi, there is a major difference. Let's say the period equals 5 seconds, okay? Putting this 5/2 pi in your calculator is not the same as 5 divided by the product of 2 pi. You're dividing by 6.28. You have to get an answer less than 1 in this case. So please be careful. This is the correct way. This is the incorrect way. Use the parentheses. After that, you'd be squaring both sides and then order of operations. But the biggest issue that I've seen over the years is what to do when you're dealing with that 2 pi. Just put it in parentheses. Other than that, the homework that goes with this should be associated with both of these new expressions and the concepts that go with. Nothing too crazy that you can't handle. But if you have any questions, you know where to find me. You can email me anytime, or you can visit me during office hours for just a couple minutes to ask a quick question and then get out of there. So hope you're all doing well. Again, hope you had a good 4-day weekend and you take care of yourselves.